In the last 30 years, there have been 198,728.5 man-hours spent in space, which is around 8,280 days of manned spaceflight. Maintaining and monitoring crew health is vital for the success of a space mission, from the pre-flight prep to the onboard exercises to the post-mission rehab. Every day, we use certain muscles called anti-gravity muscles to support ourselves against the force of gravity. For example, our quadriceps, back and neck muscles, and calf muscles. Looking specifically at exercise and movement, in an environment with microgravity such as space, the body mass is no longer required to work against gravity, and therefore loses one of the major stimuli of muscle growth, eccentric contraction of the muscle. This results in a rapid decrease in muscle mass, or atrophy, and a change in muscle composition, also known as space deconditioning syndrome. Studies have shown that on missions lasting between 5 to 11 days, there is typically a 20% loss of muscle mass. On a physiological level, the lack of gravity causes decreases in enzyme levels, number of capillaries, and the number and size of mitochondria. It has also been shown to change the ratio of type 1 fibers to type 2, making the muscle more anaerobic. So, if you are someone heading to space, you understand that maintaining your strength and endurance to complete extravehicular missions in space is absolutely necessary. It's especially important to ensure that you are capable of performing emergency procedures towards the end of the mission when you are at your weakest. But no worries, we're here to help you stay strong.
Currently, astronauts use a few different types of exercise equipment to stay in shape while they are in space. These include a cycle ergometer with vibration isolation, a treadmill, and a resistance exercise device. The cycle ergometer is essentially a stationary bike the astronauts harness themselves onto and use for cardio exercise. In addition to working the lower body, the cycle ergometer can be altered to be used as an arm crank, therefore exercising the upper body as well. The treadmills used in space include harnesses, and they apply a load to the user that increases as they work out to change the intensity of the workout. The resistance exercise device helps preserve strength of muscle and bone density by mimicking the use of free weight exercises such as deadlifts, squats, and calf raises on Earth. This machine is able to target several different muscle groups, so it is considered to be a total body workout device. But not all of your muscle groups are being exercised with these machines.
The current exercise machines astronauts use are helpful in working the muscles of the upper and lower body. However, these machines do not focus on exercising the muscles of the neck. The neck muscles, such as the sternocleidomastoid muscles, are important in holding the head steady, moving the neck, and help to elevate the rib cage, pulling more air into the lungs. Recent studies have shown an increased risk of intervertebral disc herniations, especially cervical herniations, between the base of the skull and the neck in astronauts. It was previously thought that this back pain was caused by fluid swelling in spinal discs during the unloaded, no-gravity state, but new studies have shown minimal shape changes in the disc. The mechanism that causes the cervical herniations specifically are currently unclear. Due to the prevalence of these cervical herniated discs, we have designed a device that provides a solution by focusing on strengthening the muscles of the neck.
There are 5 ways to strengthen the muscles of the neck. This includes machine flexion, extension, lateral flexion, rotation, protraction, and retraction. Machine flexion would be moving the chin to the chest, and extension is moving the chin in the opposite direction away from the chest. Lateral flexion of the neck involves side-to-side movement, bringing the ears to the shoulders. Rotation exercise involve moving your head so that you are looking to the right and left. Lastly, protraction and retraction involves moving your neck forwards and backwards as the head leads the chin forwards and backwards. Our unique design focuses on 4 main movements of the neck: forward and backwards tilts and side-to-side tilts.
When creating a piece of equipment, the metrics needed in a space environment will look a bit different than on the ground. Some requirements will be similar to typical exercise equipment, such as safety, durability, and effectiveness. Specific ISO and ASTM standards were followed for the safety and durability metrics as shown in this table. The device will be considered effective if it prevents atrophy of the scalene and suboccipital muscles and can be tested by measuring the volume of neck muscles using MRI. The equipment must be scalable for multiple users. However, NASA places a height restriction between a height of 58 to 76 inches, and assuming that NASA also requires them to be in shape, the weights will not differ drastically within male and female groups. The mass of the equipment and dimensions are particularly important in space due to weight and spatial limitations in a spacecraft. The bands used must have adjustable tension up to 50 pounds in resistance and be able to be changed based on the strength of the user. Therefore, depending on your training regimen, you can choose a resistance that works for you. Finally, the equipment must be water resistant to withstand moist conditions due to sweating, which aligns with IPO 4 drip standard.
This new piece of equipment, the NERD, short for Neck Exercise Resistance Device, comes with a semi-elastic band that can wrap around your head and fasten with Velcro. This is the perfect device to help you exercise the scalene and suboccipital muscles of the neck, known to maintain posture and provide movement. It works similarly to the VertiMax elastic band resistance device used for resistance training in athletes. The band will be used while sitting strapped into the ergometer or strapped onto the treadmill to increase stability. The band will have attachment areas on the front, back, left, and right side of your head. These will attach to one of 2 elastic bands on a mat lying in a cross on the ground. To adjust the resistance of the elastic band, you can push down on the band to disengage it from the cam cleats and pull one side out in set intervals every 6 inches to create up to 50 pounds of resistance. Resistance minimums and maximums can also be adjusted by changing the diameter of the bands, where a smaller diameter would be for someone that needs less resistance. This can be explained by looking at the equation for the modulus of elasticity. We know that Young's modulus, Y, is equal to the stress over strain. If we rearrange this equation, we see the direct relationship between area and force, which shows that the thicker the band, the greater the force output, and therefore the greater the resistance.
Overall, we present the NERD to you as a promising solution to strengthen neck muscles in space. When you think of NASA equipment, you may worry about breaking the bank, but for a limited time only, you are able to purchase this equipment for a low price of $2,999.99 through our 24/7 line 1-800-NERD. We hope you choose to make the smart decision and purchase the NERD today. Standard shipping and handling rates may apply.